Today we're going to look at significant figures in calculations. So we talked about the different rules of significant figures, and we'll review those in just a moment. But we also need to know how to determine how many significant figures to report in our answer, whether we do multiplication, division, addition, and subtraction, whatever we're doing, how many significant figures do we hold. And then towards the end of the video, we're going to talk a little bit about error and percent error. So this video is a really important video. We are going to be looking at these things all year. On your performance assessments, on your test, you're going to be looking at error and percent error. You'll get points taken off if these aren't reported correctly, as well as reporting the correct amount of significant figures in all of your calculations on quizzes and tests as well. Alright, so now that we know the importance of the video, let's review our rules for significant figures. So take a moment to think back to the last video and the rules for significant figures. Okay, hopefully you've had some time to think about it. So significant figure rules, all non-zero digits are significant. So I could have the example 3, 4, 3. So maybe 343 grams of something. How many significant figures do I have? Okay, good. I have 3 significant figures. Rule 2. Zeros between non-zero digits are significant. So perhaps I have 404 grams of something. How many significant figures do I have here? 3. The 0, even though it's a 0, it's wedged between 2 non-zero digits, so it is significant. Rule 3. Leftmost zeros in front of non-zero digits are not significant. Okay, so let's think about an example of 0.03 grams. So how many significant figures would I have here? Okay, now the 2 zeros to the left of the 3 are not significant. So I kind of think the general rule of thumb is run to the first non-zero digit, and that's where your significant figures start. So for example, run to 3, this one has 1, 2, 3. Run to 4, this one has 1, 2, 3. Run to 3, oh, that one only has 1 significant figure. And then 4 trailing zeros to the right of the non-zero digit are significant if a decimal is present. So examples of these would be 400 versus 400. Okay, how many significant figures do I have in this one? Well, I only have 1. The 4 is significant. How many significant figures do I have here? Well, I have a decimal present, so I have 3 significant figures. Perhaps it's even more precise, and it might be 400 written like so. Maybe you're estimating. You have a very precise measuring tool that's measuring to the tenths place. So now we would have not 3, but 5. So if a decimal is present, like right here, then the trailing zeros are significant. If there's no decimal present, like in the case of this 400 right here, then the trailing zeros are not significant. Okay, so let's look at a couple of examples to make sure y'all got that. Okay, so go ahead and answer these 3. I'm going to write a couple down here on Okay, so go ahead and look at these 3 numbers, 24.7, 40.79, and 9, and I don't know, we can just assume that maybe these are all in grams. It doesn't really matter for this purpose. So go ahead and answer and see if you can correctly identify how many significant figures each of these numbers has. Okay, hopefully you've had a chance to do that. So our first one, we have a 2, 4, and a 7, all non-zero, so I'm going to have 3 significant figures. In the second one, I do have a 0, but it's wedged between 2 non-zero digits, so I'll have 1, 2, 3, 4 significant figures. And in the third one, I have a 9, and I do have 3 zeros, but they're trailing zeros and a decimal is present, so I will have 4 significant figures. It's also important to note scientific notation. So this is something you should have been dealing with in your math classes or possibly even your science classes in the last couple years. So let's look at an example of scientific notation and then kind of link it back to how the rules for significant figures pretty much apply in a very similar way. So we can look at the number perhaps 83,000, okay? So for scientific notation, I need a coefficient and then to multiply it by 10 raised to a certain power. So the coefficient will always need to be a number between 1 and 10. Okay, so my decimal is going to be here, and I need to make this number between 1 and 10. So I'm going to move it 1, 2, 3, 4 times. Now I have 8.3 as my coefficient, and it is between 1 and 10. So I need to multiply that by a power of something. Now, I know 83,000 is a big number, so I'm going to multiply it by a positive power. 1, 2, 3, 4. So I have 8.3 times 10 to the 4th power. And this is a good way that I can represent large numbers in a simpler way. And we deal with really large numbers, large quantities in chemistry, and we deal with really small numbers as well when we're talking about something like the atomic radius or something like that. So we're going to deal with a lot of really big numbers and really small numbers, so we'll use scientific notation a lot. However, this is a significant figure video, so when we're talking about significant figures, the same rules apply. I have 2 non-zero digits, so I would have 2 significant figures in this, 2 sig figs in this number right here. I can look at another example of how, let's see. So let's look at another example here. I could have like 7.0 times maybe 10 to the negative 15. So this, because it's to the negative 15, would be a really small number. But how many significant figures would I have here? Well, I have a non-zero digit, so that's going to be a significant. I have a trailing 0 and a decimals present, so I would have 2 significant figures or 2 sig figs in this number. Okay, now let's talk about how we determine significant figures through calculations. All right, so let's look at the rule first for calculations involving addition and subtraction. So the answer to an addition or subtraction calculation should be rounded to the same number of decimal places, not digits, as the measurement with the least number of decimal places. So let's look at an example of that. Let's say I gathered 3 separate calculations. 12.52 meters, 349.0 meters, and 8.24 meters. So these are my 3 sets of data, and perhaps I need to find the total number of meters the ball traveled. Maybe I gathered data 3 separate times for this. So I need to add these numbers up. So I'm going to look, and when I add them, I'm going to get the number 369.76 meters, okay? Now, if I add all these numbers up, this is what my calculator is going to show me. However, I need to represent it in the appropriate number of significant figures. So let's look. The rule says that I need the same number of decimal places as the least number. So what has the least number here? Let's see. I have 2 decimal places there, 1 decimal place there, and 2 decimal places there. So what has the least? Well, this number right here. So my answer needs to only have 1 decimal place as well. Okay, so I currently have 2 decimal places. Well, the 6 is greater than 5, so that is going to round up to an 8. So my answer, written with the correct number of significant figures, would be 369.8 meters. Okay, so you want to be really, really careful when you're taking quizzes, taking tests, doing your labs, that when you're doing addition and subtraction, you're not just reporting the number that your calculator spits out, that you're paying attention to your significant figures and the data you're collecting from the instruments that you're using, as well as when you're doing your calculations, rounding appropriately as needed. So let's also now move on to multiplication and division. The rule is a little different. When dealing with multiplication and division calculations, it's going to be a little different. We're not going to worry about specifically places after the decimal, but significant figures in total. So we mostly do multiplication and division calculations in chemistry. It's important to remember both, but this is the one that you'll use a lot. So we could look at an example here. Perhaps I have 7.55 meters and I need to multiply it by 0.34 meters. Okay, and if I put that into my calculator, I'm going to get the number 2.567 meters squared. Okay, now this is what my calculator is going to tell me. We know that that's not right. So let's look at the total number of significant figures I have. In this number, I have 3 significant figures. And in this number, remember the 0 doesn't count. I'm going to run to the first non-zero digit, so I just have 2 significant figures. So in my answer, I'll only need 2 significant figures. So I'm going to round that to give me 2.6 meters. So my answer there would be 2.6. So I know that I said we're going to look at error analysis. I think I'm going to make a separate video on error and percent error and what all that means to avoid this video being a little too lengthy.